Welcome to this screencast. We've got 5.1 using fundamental identities. In this screencast and maybe a next one, we will go through the categories of trigonometric identities. You will not be provided with any of the information. The identities look a lot like formulas. You will not be provided with these for our assessment. So you'll have to memorize them. There's another screencast about tips on memorizing, but the purpose here is to give you the context to the greatest extent manageable without reteaching trig about what are these things. Well, first of all, an identity, the definition of an identity is it is an equation. Looks a lot like a formula, but it really isn't. It's an equation that's true for all values of the variable. Okay, notice this, unlike a formula, only has one variable in it, right? Because it has different functions in it, then those functions operating on that value are going to make certain numbers. And then to make this equation true for all values of that variable, you have some different things going on. So first and foremost, we have reciprocal identities. Okay, so with that definition out of the way, these ones I think would be the most familiar because you've seen this in primary trig before, and we've talked about reciprocals, based on the x-coordinate and so on and so forth. So what you got here, the reciprocal identities saying that all of the primary three ratios, sine, cos, and tan, have something called reciprocal. The definition of reciprocal in mathematics is 1 divided by that thing. Okay, and so sine, its reciprocal is cosecant. So what all it's saying is if you have cosecant, maybe the best one to start with, it was defined as the reciprocal of sine. So down there in the bottom left corner, that's where we start. Well, then the same is true if you do 1 over cosecant of some value, then you're also going to get the same value when you just have sine, right? So because cosecant is 1 over. So you're kind of doing 1 over sine, and then that is what produces sine. Okay, you're just going to memorize those, and you might wonder, how am I going to be evaluated with respect to these? Well, we'll get some examples in just a second, so maybe walk through a series of these identities first, and then I'll show you how you might actually use them. Really what you're going to do is be simplifying expressions. I'm going to cut to the chase here. You're going to be simplifying some expressions. So those are reciprocal identities. You're going to memorize those. You're going to memorize that sine has a reciprocal called cosecant. And then if I do 1 over sine, that's how I arrive at cosecant. And if I did 1 over the cosecant, I would actually get back to sine. And then the same is true for both cosine and tangent. Okay, that's it for those 6. So there's 6. One category called the reciprocal identities. Moving on to quotient identities. So-called, I realize that reciprocal looks a lot like division, but these ones are actually officially called the quotient identities. Some people just nickname the one on the left the tan identity. Technically, there are 2 quotient identities because you can, if you understand that tangent, and I'll get to the explanation in just a second, but if you can understand that tangent is sine over cosine. So again, it's a value. You would be operating on some angle, like I've drawn in that triangle. You'd be performing the tan ratio of some angle. Well, that's equal to doing the sine ratio of the same angle divided by the cosine ratio of the same angle. Okay, that's an identity, true for all values. Lost my train of thought there about why there were 2 of them. I'd have to rewind myself, so I won't do that. But yeah, there are 2. The cotan ratio was also defined, as we see over there in the bottom right-hand corner. And again, we defined these before with thetas. But our textbook actually uses a mixture of u's and thetas, so that's why I present it with different letters to stand in for the angle. Anyway, back to it. Cotan was defined in our first trig section as the x-coordinate divided by the y-coordinate, and so that's why it lands as cosine over sine. Okay, once again, this is information based on, well, right-angled triangles. The quotient identities gets more, though, into the relationship on the unit circle. So remembering that the unit circle has an equation, x squared plus y squared equals 1. Because any circle is x squared plus y squared equals r squared, and the unit circle is so-called because it has a radius of 1. Okay, there's 2 more quotient identities. So in categories so far, we have one category called reciprocal identities, a second category called the quotient identity. So that makes 8 separate piece of information you had to memorize, I guess, but you could start to just chunk it into categories. And maybe you want to follow along with the names that we call them, quotient identities, and then you'll have a handle on them. Once again, not offering really any way that you're going to be using these just yet, but that'll come up in just a little bit. The next identities that come along are known as the Pythagorean identities, and they are so called because they are very closely linked to the Pythagorean theorem. And once again, that equation of the circle that you see there. Okay, so putting together, understanding that the unit circle has any point along it at a coordinate x, y. What we talked about was actually the y coordinate really is the sine ratio of that angle u, and that the x coordinate is really the cosine ratio of that angle u. So, really, I guess if I switched up the order here, we'd have x squared, y squared. I mean, that's the same thing though, right? Because on the unit circle, x here is cosine of u, and y is sine of u. That's what we've got. Any point as you go along the unit circle, that's the definition of our trig functions when we're on the unit circle. Okay, and there you go. That's all you need to know, really. And that sets out three relationships, actually, starting with this one, though. I call this one, I've probably made a bunch of videos, so I call it different things in different videos, but that's the centerpiece, or the fundamental Pythagorean identity is that one there. And yeah, not too sure why we would have put sine first when the equation's x squared plus y squared equals 1, but there lo and behold, we put sine squared u plus cos squared u equals to 1, probably because cosine is the code of the sine ratio, and so sine, I guess, goes first of all. But there you go. No big deal. What you're going to see next is how we can arrive at these other two. And once again, these three need to be memorized. I have another video where I got tips on how to memorize them, but at the end of the day, you're just going to have to memorize them. What I'm about to show you is how they become identities, and like what algebra manipulation takes the fundamental one here, the one I got the red box, and how you can turn it into, how it actually is the same truth over there with those other ratios. Yeah, that'll be shown here in just a second. Before that, though, I did pause here and also want to make a note that both with reciprocal identities, because I wait till now because the squareds start to come up here. I did want to pause and make a note that, back when we did reciprocal, it just said secant u equals 1 over cos squared u. But it's also true if you raise it to the power of 3 or 4 or 5, that like cos to the 5u would be equal to 1 over cos to the, did I say secant? Sorry, secant to the 5u would be the same as 1 over cos to the power of 5, because you're just repeatedly multiplying by fractions. And then the same is true with those quotient identities. I've just got tangent written there, but like, yeah, tan squared u is equal to sine squared u over cos squared u. And if you cubed it or fourthed it, because again, tangent is really a ratio of these ratios, and since it's written as a fraction, you just keep multiplying by the fractions over and over again. Okay? Okay, so back to Pythagorean identity. So 3 more here. Who's counting? We're up to 11. Piece of information. We may wonder why is this top one actually, how does this fundamental one that I called it over here on the left, how does that actually turn into the two others? Well, the first way that you can understand this is, as I've noted over here, you know what, I'm going to divide by, sine, let's go sine squared first. Like, what would happen if, this is actually getting into the types of problems that you might have. It might be a problem that would say, show that, it might say, show that this is true. That's what we're going to get into, is show that this is the same. Okay, so how would you go from here to there? Well, you'd start with, obviously, you'd start with sine squared u plus cos squared u equals 1. And you know a bunch of algebra, and it wouldn't take you too many guesses and checks before you decided to divide everybody maybe by sine squared u. You're allowed to do that, right? In an equation, you can go ahead and divide by anything you like. So we'll divide this by sine squared u. Can't divide by 0, of course, but sine squared u and got to divide that by sine squared u. And now, again, putting into practice some of the types of questions that you might get involved in. Well, what is this thing? Now that on the right-hand side is 1 over sine squared u, well, that's a thing. Hang on a second. Rewind me back about 7 minutes. I just talked about 1 over some things that involve sine. Yes, indeed, that is equal to cosecant squared u. And hang on a second. This is looking like something over here. Sine squared u over sine squared u, that's equal to the number 1, obviously. And cos squared u over sine squared u, that is cotan squared u. So really what happened is we took an identity and we algebraed it and we turned it into another relationship. Actually, it's the same relationship, it's just in a different form. If this is something that you're enjoying, then you came to the right place, because in this chapter we have an awful lot of this stuff. And it's really, actually, you know, what it's good for is practicing spotting these relationships, spotting patterns, putting your algebra to a context where you've never really done it before. We're obviously way far away from, you know, y equals mx plus b, or, you know, factoring or anything like that. But we need to, once again, on the pathway to calculus here, refine your algebra. And this trig is really good for that. There's some other applications to it too, but it's really, really good at helping you with your algebra skills. Why don't you pause the video right now and actually do the show that would get us to that middle one. A little hint over here in the right-hand margin, you know, in the top there, divided by sine squared u across the board. You try and get to that one in the middle. Pause the video and give that a shot. Okay, well, either you paused or you just waited through the 3 seconds of me just being silent, and you started once again with sine squared u plus cos squared u equals 1. And once again, if you are wondering what's with the u, how come it's not theta? It's just really a placeholder, folks. There has to be an input. When you have a trig function, something has to be inputted. Theta is very common, definitely in triangle type questions, but it could be anything. We'll see x in there, or u, could be anything. Okay, so you don't have a problem with that now. Perfect. You hopefully divided everybody through by cosine squared theta, like you were supposed to, and you will have seen a great revelation. Before I get to that, remember that each of these terms individually get divided by that, and that's what's going on. You might have tried and only divided that one, and maybe you were left with still sine squared u, but you weren't supposed to do that. It turns into tan squared u, because you remember from a couple slides ago. That's an identity, and this is the number 1, and this is one of the reciprocal identities that gets us to the magic. It's not really magic, it's just that identity right there. Okay, that is a quick run through of some of the things that we do here with trig identities, and let me show you a couple other examples to wrap up this screencast about these first 3 categories. All right, simplify the expression. This is entry level. Can you simplify 1 minus cos squared theta? So when you do one of these, you go through a series of steps that I like to call recognize, remember, rearrange, replace. Now, you don't always do that, but sometimes you do. Anyways, do you recognize anything about this? Well, you might recognize that 1 minus cos squared theta was, you know, involved. 1 minus cos squared theta isn't in that identity, but you might remember that there was a 1 and there was a cos squared theta in one of those identities. I mean, you're going to have to be able to do that. You're going to start to see this better and better each time we do it. And you do it on your own for homework. So what you notice is, well, if I rearrange sine squared theta, then I get, 1 minus cos squared theta. I subtract cos squared, subtracted cos squared from that side. So you subtract cos squared from that side, and you arrive at, well, literally the thing you're looking at here. So the answer is really sine squared theta. That's all it is. Others amongst you might have said, well, I know that I know that the number 1 itself is cos squared theta plus sine squared theta. So you might have replaced there, and then and then on the outside you still have to subtract cos squared theta. Some people do that way too. And then what that's saying is cos squared theta plus sine squared theta minus cos squared theta, and that's just equal to sine squared theta as well. Okay, so that is one example of just a straight ahead simplify, and that's where I'm going to finish. Okay, so you have to put in the memory work, and then what are you going to do? You're going to have to recognize, remember, see if there's some algebra that you can mess with, and that is called simplifying identities. All right, stay tuned for part 2.